Dear learners, welcome you all. The learning outcome is analyze the performance of transformer by various testing methods. The specific outcome is testing of transformers. In that we are going to discuss about OC and SC test. For more reference, refer Narthan IJ and Gothari DP electrical machines. Testing of transformer. What is the necessity for testing of transformers? The testing of transformer is needed for proper fabrication and to ensure hassle-free operation. Transformers are tested for finding out losses, efficiency, regulation and temperature rise. Testing of transformer is classified into two types: direct test method, indirect test method. In direct test method, we are going to discuss about load test method. This has been discussed in the previous class itself. In indirect method, we have open circuit short circuit test, synchronous test, and separation of no load losses. So it may be a direct test method or indirect test method. In both the situations, we are going to find the efficiency of the transformer. Now we are going to discuss about polarity test of transformers. Polarity means the direction of the induced voltage in the primary and the secondary winding of the transformer. The two transformers are connected in parallel, then the polarity should be known for the proper connection of the transformer. The polarity test is very important because to find whether the voltage is added or voltage is subtracted. Here, the polarity test of the transformer is classified into two types. First one is called as additive, the second one is called as subtractive. Additive and subtractive. What is additive? Polarity. In additive polarity, the same terminals of the primary and secondary windings of the transformers are connected together. Subtractive polarity. In subtractive polarity, different terminals of the primary and secondary sides of the transformer is connected. The polarity is classified into additive polarity and subtractive polarity. This is the circuit diagram of the polarity test of a transformer. This is your order transformer. This is your primary winding. This is your secondary winding. The purpose of this order transformer is to vary the voltage from 0 to maximum. To this primary winding, we are going to connect a voltmeter V1. This voltmeter is going to measure the voltage, primary voltage. This is your secondary winding. We are going to connect a voltmeter across this secondary. It's going to measure the secondary voltage. Another voltmeter is connected, is called a V3 voltmeter, is connected between the primary and secondary. This voltmeter will decide whether the polarity is added, whether this voltmeter V3 will decide whether the polarity is added or polarity is subtractive. How it is decided? So how we are going to decide? So in this, in additive polarity, the terminals of primary terminals A1 and secondary terminal A1 both are connected together, and A2 of primary and A2 of secondary, if are joined together, this will decide, is called as a additive. Subtractive is nothing but A1 of primary and A2 of secondary are joined together, and A2 of primary and A1 of secondary are joined together, is called as subtractive. So this is it. If A1 is connected to A1, A1 is connected to A1 and A2 is connected to A2, that means the terminals of the transformer are connected, then the additive is said to be added. So in this, the voltage induced in the primary winding and the voltage induced in the secondary winding, both the voltage added together. So that's this is your primary voltage, this is your secondary voltage. These two voltages are added and this will be shown in the voltmeter V3. This is called as a additive polarity. Subtractive polarity is nothing but same thing. If A1 of primary is connected to A2 of secondary and A2 of primary is connected to A1 of secondary, it is differential. It is of opposite polarity. If A1 is connected to A2 and A2 is connected to A1, that means it is of opposite terminals are connected to each other. Thus, the voltmeter will read the subtractive polarity. The voltage in the primary winding and the voltage in the secondary winding will be the difference shown in this voltmeter 3. This is a polarity test of a transformer. Next, we are going to discuss about open circuit and short circuit test. This is a very important test. In this, by conducting this test, we can find the efficiency of the transformer, as well as we can draw the equivalent circuit of transformer, as well as we are going to find the regulation. Open circuit test and short circuit test are performed on a transformer to determine the equivalent circuit of a transformer, voltage regulation of a transformer, and efficiency of a transformer. If you want to find equivalent circuit, efficiency and voltage regulation, we have to conduct open circuit and short circuit test on a transformer. This is the indirect method of finding the efficiency. In the previous lecture or previous video, we have discussed about load test on single phase transformer. It is in that we are going to load the machine directly so that we can find the actual efficiency. In this, we are not going to find the actual efficiency. So first, we are going to discuss about open circuit test on transformer. This is your open circuit test. This part is called as a variac. From the variac is given to the ammeter and voltmeter, and you will be having a two winding transformer. So this open circuit test will be conducted on low voltage side. High voltage side will be left open. So for open circuit test, we are going to leave the high voltage side open. So open circuit test or no load test on transformer is performed to determine no load loss or core loss and no load current I0 in transformers and parameters of the equivalent circuit of the transformer. So by conducting this open circuit test, we are going to find the core loss. The purpose of open circuit test is to find the core loss of a transformer. When conducting these experiments, this high voltage side should be kept open. The high voltage side of a transformer is kept open. So this is your I0. Load is not in this. We are not going to apply the load at that condition. By wearing this transformer, we have to apply the rated voltage of the secondary. In that, we are going to measure the current I0, W0 and V0. These three voltage, current and power are the no load current, no load power and no load voltage. For this test, we have to apply the rated voltage. Let us now discuss this open circuit test on a transformer with the lab experiment. This is your lab experiment setup. Phase neutral. This is your single phase variac. You can vary this voltage from 0 to 270 voltage. And this is a two winding transformer. In this, we have to take a two winding transformer. The two winding transformer ratings are 115 volt by 230 voltage. So low voltage side is 115, high voltage side is 230. The capacity of the transformer is 1 kVA. So by conducting this open circuit test, we are going to find the core loss of the transformer. So for this high voltage side should be kept open and we have to apply the rated voltage. For this transformer, the voltage is 115 voltage and 230 voltage. The connection is given to low voltage side. For the low voltage side, the rated voltage is 115. So by varying this order transformer, we have to keep this rated voltage as 115 in this voltage and we have to measure the current. So this is your V0 voltage. The V0 voltage can also be represented as V1. In this voltmeter, we are going to keep the rated voltage as 115 because this is your rated voltage of this transformer. After keeping this 115 voltage, we can measure the current I0 and we can measure the W0 by using this wattmeter. When conducting this test, remember this high voltage side should be kept open. So this is your tabular column, serial number, voltmeter reading, ammeter reading and wattmeter reading. So in this we are going to measure the voltage. So by variance order transformer, we are going to keep the voltage as 115 voltage. 115 voltage. After keeping this, the current is 0.5 amperes and the power may be 75 watts. This is the experiment setup, and you have to take only one set of reading. From this, you are going to calculate. So usually high voltage side winding is kept open and low voltage side is connected to the normal supply. The wattmeter, ammeter, voltmeter are connected to the low voltage side as shown in the figure. Now applied voltage is slowly increased from 0 to normal rated value of the low voltage side with the help of a variac. When the applied voltage reaches to the rated value of the low voltage side, readings from all the three instruments are taken and tabulated. So for the open circuit test of a transformer, this is the open circuit test, we are going to use the formulas. The no load shunt parameters are calculated from the open circuit test. So W0 is the iron loss or core loss or no load power. V0 is your no load voltage, I0 is your no load current. These are the three values we have found from the open circuit test and has been tabulated. From these values we are going to find the parameters. So no load power is equal to W0 is equal to V0 I0 cos theta naught. We know this W0, we know this I0 and V0. So we are going to calculate the cos theta naught, is also called as a power factor. It's called as a no load power factor. So cos theta naught is equal to W0 divided by V0 I0. Once the power factor is obtained, the no load component current are determined as. So this is the equivalent circuit. In this you are going to find the I mu and IWIC. These are the components. So magnetizing component and no load current is called as the I mu or Im is equal to I0 sin theta naught. Working component IW or IC is equal to I0 into cos theta naught. These are the two components. So when IC is equal, I0 is equal to IC plus I mu. When you add these two components, you get the no load current. Then next you are going to find the magnetizing branch reactance. In this you are going to find the reactance value. X0 is equal to V0 divided by I mu. So V0 and V1 both are same because this is connected in parallel. For parallel connection the voltage will be same. So if we want to find the value of X0 from the value V0 or V1 divided by I mu, we have found the I mu value here. So we can find the reactance value. Next is the resistance parameter. So we can find from V0 divided by IW. IW is nothing but working component. From this you can find the value of R0. This is your no load parameters. These values are found from open circuit test. Next we are going to find about short circuit test. A short circuit test of a transformer is mainly conducted to find the copper losses. This is a circuit diagram of a short circuit test. In this, the secondary side is short circuited. Remember this, once again I repeat, in short circuit test of a transformer, the secondary is short circuited, or we are going to work on the primary side, or we are going to work on the high voltage side. When conducting this experiment, the secondary or low voltage side should be short circuited. For this, we have to apply the rated current. In this, we are going to find the VSC is nothing but short circuit voltage, ISC is nothing but short circuit current, and WSC is the short circuit power. So the short circuit test on transformer is performed to determine the copper loss on full load. The copper loss is used to find the efficiency of the transformer. When we short circuit the low voltage side, we are going to find the copper loss on full load. WSC is the copper loss. So find the equivalent resistance, impedance and reactance. From this we are going to find the value of equivalence resistance, impedance and reactance. So in this the low voltage side is short circuited. In this you are going to apply the rated current. This is your short circuit current. Now let us discuss with your lab experiment setup. This is your short circuit or single phase transformer, single phase variac. Same as we discussed, 115 voltage, 230 voltage. This has been taken. 1 kVA transformer has been decided. Here the secondary is short circuit, nothing but 0 to 115 voltage is available. That side is short circuited. In short circuit test, we are going to apply the rated current. After applying the rated current, we are going to tabulate in this tabular column. How we are going to find the rated current? We know that this transformer has capacity as 1 kVA. 1 kVA is nothing but 1000 volt ampere. In this we are going to measure the short circuit current, V is a short circuit voltage, and WSC. Now how we can find the rated current? Here the transformer capacity is 1 kVA, 230 bar 115 voltage is your transformer specification. So transformer capacity is 1 kVA is equal to 1000 volt ampere. We know the primary voltage as 230 voltage and secondary voltage as 115 voltage. So in this we are going to find the primary current as well as the secondary current. So how we are going to find the primary current? Where the capacity is given as 1000 volt ampere, we know the value of voltage, need to find the value of current. So primary rated current is equal to 1000 divided by 230 will be about 4.34 amperes. Similarly, for a secondary rated current is 1000 divided by the voltage available in secondary is 115 is nothing but 8.69. Here the connection has been given to the primary side and secondary has been short circuit, so we have to apply the rated current of 4.34 amperes. By varying this order transformer, we have to going to keep the current as 4.34 amperes. From this 4.34 amperes, we can measure the short circuit voltage and short circuit power. This is your short circuit current, 4.34 amperes. Then get voltage is 56 voltage, and by what made it power as 18. So this is your copper losses. This is how we are going to conduct the experiment for a short circuit test. From this test, we are going to calculate. From the test results, we determine the series branch parameters of an equivalent circuit as R equivalent, X reactance. So WSC is a full load copper losses. When we short this secondary side, we will get this total power as copper losses, full load copper losses. So from this we can find the equivalent resistance on high voltage side. So R01 is equal to WSC divided by ISC square. WSC is a full load copper loss, ISC is a short circuit current. Equivalent impedance referred to high voltage side Z01, VSC divided by ISC. VSC is nothing but short circuit voltage, ISC is nothing but short circuit current. Equivalent leakage reactance referred to high voltage side. So leakage reactance X01 is equal to root of Z01 the whole square minus R01 the whole square is giving you the leakage reactance. These are the parameters we are going to find from the short circuit test. Next we are going to find the short circuit power. Cos theta SC is equal to WSC divided by VSC into ISC. Generally for a single phase supply the power is equal to VI cos theta. So from that you are going to find the cos theta. So power divided by voltage into current. This is short circuit power factor. Now we are going to find the equivalent circuit of a transformer. This has been discussed in the previous class itself. For a fast recall, just discuss it. This is your transformer. This is your primary side. This is your secondary side. In primary side you have R1 X1. In secondary side you have R2 X2. These are the parameters we are going to discuss, and we are going to find R0 X0, I mu, IW, I0. These are the values we are going to find. So the equivalent circuit is nothing but after finding the value, we can shift the secondary to primary side, or this primary resistance or secondary resistance to secondary side refers to. So based upon that, this is your final equivalent circuit. When we are transferring the value from the high voltage low voltage side or low voltage high voltage side, this has to be followed. When transferring the resistance and reactance from secondary to primary, it should be divided by K square. Again, when transferring the resistance and reactance from primary to secondary, it should be multiplied by K square. When you are transferring the voltage or current from primary to secondary or secondary to primary, it only K is used. So remember this, from the open circuit to short circuit test, we are going to find the equivalent circuit parameters. So efficiency and regulation. From the open circuit short circuit test, we can also find the efficiency and regulation. The formulas are: the output power is equal to X into kVA into cos theta in watts. What does this X? X is the percentage of load, fraction load. It may be 0.5 voltage, 0.7 voltage, 1. That is a load which you are going to apply. We are going to assume this value. X is the fraction of load. kVA is the capacity of the transformer or power rating of the transformer. Cos theta is the power factor. So to find the efficiency of a transformer, first thing is required is output power X kVA into cos theta. This is what you are going to find. X is a fraction of load. We are going to assume this value. Next, copper loss, X square into WSC. X square is nothing but the fraction of load which you are going to use here. X square into WSC is nothing but copper losses which has been found using a wattmeter WSC in the experiment. This is conducted from the short circuit test. So WSC is a copper loss in short circuit condition. So X is nothing but fraction of load. So total loss is equal to copper loss plus iron losses. Copper loss we have decided from the percentage of load. Iron loss that we found from the open circuit test. That in that we have a W naught. That is called as the iron losses. So we are going to find the total losses. So efficiency is equal to output power divided by output power per total losses. Output power we have calculated here. So output power plus total loss we have calculated here. Next is your efficiency. So efficiency is nothing but, next is your regulation. Next is your regulation. So we are going to find the value X ISC. X is nothing but percentage of load. R02 is a parameter, cos theta plus or minus X02 sin theta divided by V20 into 100%. So this is your regulation value. The plus and minus belongs to lagging and leading. So V20 is your open circuit voltage on high voltage side, and plus for lagging and minus for leading. This is very important for the finding the efficiency and regulation. From this data you can tabulate. From that data we are going to find the efficiency. So we are going to find the power factor, and we are going to assume the power factor as 0.2, 0.4, 0.6, 0.8 and 1. So load I am going to assume as 1 by 4, 1 by 2, 3 by 4 and 1. This is your fraction of load I have assumed. So for this we have to find. So from the core losses W0 you have right here, kVA transformer is 1 kVA and rated secondary current ISC, from that 4.34 amperes, and short circuit power is nothing but full load copper losses. From this you can find the efficiency of this transformer. So from the previous problem, so efficiency can be calculated and tabulated here. Same thing for your regulation also. 0.2, 0.4, 0.6, 0.81. We are going to assume these values. For this is your percentage of load. X is equal to 1 by 4, X is equal to 1 by 2, X is equal to 1 by 3, X is equal to 1. So substitute this value as 1 by 4, lagging and leading. Lagging, what is the lagging, what is leading? So based upon this you can change this value. Substitute this. So this is your how we are going to find the efficiency and regulation of a transformer. This is conducted by open circuit and short circuit test. So from the data you are going to draw the graph. Power factor is efficiency, and from the regulation unity power factor, lagging, leading, regulation. We can tabulate it here. Hope all have understood the concept of open circuit and short circuit test. Let's all meet in the next session. Thank you.